The morning of February 20th, 1943, north of Kasaran Pass in Tunisia, delivered a profound shock to German tank commanders, the reality of which the subsequent battle reports would struggle to accurately convey. Through the dust and smoke of the North African battlefield, American Sherman tanks executed coordinated maneuvers that flatly defied everything established Wehrmacht doctrine claimed was possible without relying on visual signals. 5 Sherman tanks, separated by the broken terrain with no direct line of sight between them, converged upon German positions with almost supernatural timing. There were no flags, no flares, and certainly no dispatch riders racing between the vehicles. Instead, they moved as a single, cohesive organism, each tank covering the blind spots the others couldn't see, every crew knowing precise position of their comrades. Inside the German Panzer IVs, equipped with the standard Fuji 5S radio sets, commanders fought a losing battle against the inherent limitations of their communications. Their amplitude modulation, AM, systems were overwhelmed by engine noise and battlefield static. The 10-watt German transmitters, while state-of-the-art by 1930 standards, could barely penetrate more than a few hundred meters, particularly when the tanks were in motion, and most German tanks carried only receivers, rendering them incapable of reporting observations or calling for necessary support. The Americans were, in fact, operating with a technological paradigm the Germans had not yet grasped. Frequency modulation FM, radios in every single tank, utilizing crystal control precision and 25 watts of transmission power, delivering a clarity that cut through the engine noise and battlefield chaos like a knife through paper. 8,000 miles from Detroit's assembly lines, the most decisive technological advantage of World War II was revealing itself. Not in armor thickness or gun caliber, but in the invisible realm of electromagnetic waves. The true revolution lay in a robust communication system that networked every American tank crew in ways the German Wehrmacht never conceived possible. This strategic transformation began decisively on July 22, 1941, when the United States Army standardized the critical signal corps radio sets, the SCR-508, SCR-528, and SCR-538, for integration into all medium tanks. While German forces advanced through the Soviet Union utilizing tactics dependent upon amplitude modulation, AM, radio communication between command vehicles, American engineers at the Galvin Manufacturing Company, later globally renowned as Motorola, were pioneering frequency modulation, FM, technology destined to render German systems obsolete. The success rested on a dedicated engineering team, notably Daniel E. Noble, who first conceived the military application of FM technology, and Henrik Magnoski, the principal RF engineer, who meticulously solved the immense technical challenges of installing sophisticated, sensitive electronics within the punishing environment of a tank chassis. Their 181-pound creation was not merely a radio. It transformed every Sherman tank into a resilient node in the world's inaugural battlefield network. The powerful BC-604 transmitter generated 25 watts of output, a stunning 2.5 times the power of the German FUG-5's output, operating across the 20.0 to 27.9 MHz band. The system provided commanders with 10 preset channels secured by crystal control stability. Furthermore, the dual BC-603 receivers integrated into the STR-508 allowed commanders the unprecedented capability to monitor multiple critical frequencies simultaneously, an operational advantage that would prove decisive in the crucible of armored combat. Ultimately, the fundamental superiority stemmed from Edwin Armstrong's patented FM technology, licensed exclusively to the military, which fundamentally eliminated the pervasive static and debilitating interference. The inherent limitations of amplitude modulation systems, which had long plagued effective military communications, were starkly exposed. Where German tank radios were rendered functionally useless by the electrical discharge noise of heavy combat, American frequency modulation, FM, radios delivered clear, uninterrupted voice communication, even amidst the thunder of artillery barrages. This technological advantage was first deployed during Operation Torch on November 8, 1942, as American armor arrived in North Africa. Tanks of the 2nd Armored Division landed near Safi and Fadala, equipped with the pioneering SCR-508 radio sets, which were immediately poised to demonstrate their profound superiority over standard German communications protocols. The Africa Corps, despite its status as the Wehrmacht's most experienced armor force, operated under severe and debilitating communication limitations. A standard German tank platoon, typically comprising 5 vehicles, was structured with a crippling deficiency. Only 1 or 2 tanks possessed the full two-way capability of the FUG-5 transceivers. The remaining subordinate tanks were equipped solely with FUG-2 receivers, meaning they could receive critical orders, but were voiceless, unable to respond, confirm actions, or report vital enemy positions. Consequently, the German tank platoon functioned through a rigid, fragile hierarchy, where the platoon leader transmitted orders that subordinate tanks could only acknowledge through synchronized action, not words. This vulnerability proved catastrophic. When the command tanks, easily identified by their distinctive multiple antenna configurations, were destroyed, the entire platoon instantly lost coordination and cohesion. This contrasted sharply with American forces, where the decentralized nature of FM communication meant that every tank could instantaneously assume command functions. The true measure of this disparity arrived during the Battle of Kasserine Pass, fought between February 14th and 24th, 1943. Although tactically resulting in a German victory, the engagement provided the first major demonstration of American radio superiority, revealing operational capabilities that stunned Wehrmacht observers. Even during the most confused and chaotic fighting, scattered elements of the U.S. 1st Armored Division were able to maintain seamless coordination across vast distances. American armored units demonstrated capabilities that defied German understanding, coordinating across 50 miles of battlefield. Tank crews, often strangers, executed complex, synchronized attacks, instantly warning each other threats and calling for artillery support, all linked by crystal-clear frequency modulation, FM communications. German signals intelligence units quickly intercepted these American transmissions, noting the exceptional clarity and precision of the coordination. The 10th Panzer Division's intelligence section reported that American units maintained communication at ranges where their own radios produced only debilitating static. More disturbing still was the realization that every American tank appeared capable of full transmission, not merely designated command vehicles. The German FUG-5 radios, operating on amplitude modulation AM, within the 27.0 to 33.3 MHz range, suffered from fundamental technical limitations. Their 10-watt transmitter often struggled to reach 2 to 3 kilometers even in ideal conditions. Crucially, this range plummeted to mere hundreds of meters when vehicles were moving. Every firing spark plug, electrical motor, and track movement generated interference that the AM systems could not adequately filter. When American armor arrived in Italy in September 1943, the mountainous terrain was expected to negate any radio advantage. Instead, the SCR 508's frequency modulation technology proved even more valuable, expertly handling the severe multipath interference common in mountain valleys, conditions that rendered German AM radios utterly useless. During the relentless advance toward Cassino, American tanks coordinated movements through terrain, where visual signals were impossible and German communications failed completely. American armored units executed coordinated attacks with precision that fundamentally defied established German doctrine, which mandated visual contact for effective maneuver. After-action reports from the 1st Armored Division consistently describe routine operational coordination maintained across distances where comparable German radios generated nothing but debilitating static. On June 6, 1944, as the M4 Sherman tanks churned off the landing craft onto the sands of Normandy, the sophisticated SCR 508 radio sets ensured seamless, continuous contact with crucial naval fire support, a level of integrated coordination entirely unattainable by contemporary German communications technology. Yet, the brutal, close-quarters fighting within the dense Norman bocage quickly exposed a critical, deadly flaw: a vast communication chasm between armor and infantry. The infantry's SCR 300 operated exclusively on the 40.0 to 48.0 MHz frequency band, rendering it incompatible with the tank's 20.0 to 27.9 MHz range. This frequency mismatch proved fatal in the hedgerows, allowing German infantry armed with devastating Panzerfaust to stalk and eliminate American tanks, while adjacent American infantry lacked any rapid means to transmit a warning. Resourceful American innovation rapidly mitigated this threat within a matter of weeks. By late July, in preparation for Operation Cobra, tank crews had implemented a simple yet revolutionary modification. 8 field telephones were mounted inside repurposed ammunition boxes, which were then welded to the tank exteriors and wired directly into the internal communication systems. The subsequent offensive Operation Cobra, running from July 25th to 30th, 1944, served as the ultimate demonstration of American radio superiority. Under the command of Major General Edward H. Brooks, the 2nd Armored Division coordinated over 200 Sherman tanks using robust radio networks that provided unprecedented, real-time battlefield control. German defenders, particularly the elite Panzer Division, encountered an enemy that appeared to possess an almost supernatural awareness, with American tanks responding instantly and decisively to emerging threats across the entire sector. The efficacy of Allied coordination was startling. Artillery strikes, precisely coordinated through tank radios, could be summoned within minutes of target identification, linking disparate units operating miles apart across the battlefield. This level of integrated firepower revealed a stark contrast with German capabilities. Panzer Lehr, once the epitome of Germany's premier armored prowess, had been reduced to operational communication poverty. Most of their tanks were forced to operate without radios, relying entirely on visual signals in theaters where visibility rarely exceeded 100 meters. The few functioning radio sets were plagued by interference and limited range, critically preventing effective, real-time coordination across the division. The irony was profound, bordering on strategic failure. Germany had, after all, pioneered the use of radio communication in armored warfare. Heinz Guderian, the architect of the Blitzkrieg Doctrine, had adamantly insisted on installing radio equipment in tanks since the 1920s. His seminal 1937 work, Achtung, Panzer, emphatically underscored reliable communication as a single most essential element for rapid armored operations. Guderian had personally developed the communication systems that allowed tank officers to coordinate attacks dynamically. Yet, by 1943, the very German industrial system could not deliver the radios that Guderian's own successful doctrine demanded. German production statistics laid bare the crisis. In 1943, while approximately 5,700 medium tanks were manufactured, fewer than 2,000 FUG transceivers were produced to equip them. Most of these scarce sets were allocated to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment. Meanwhile, Soviet tank forces suffered from even more extreme communication deficiencies. The T-34, the most heavily produced Allied tank model, typically entered combat without any radio equipment whatsoever, forcing Soviet doctrine to rely on flag signals and rigid pre-battle planning, often with catastrophic consequences. Though Lend-Lease provided vital relief by 1943, supplying American equipment, including the robust SCR-508 radio sets, to Soviet command tanks, the technological disparity between the Allies remained stark following the initial German successes of 1941. The Soviet Union, struggling throughout the conflict to maintain supply lines, ensured that barely 25% of its armored vehicles were equipped with any radio communication system by the war's conclusion. This situation sharply contrasted with the monumental American industrial achievement. The United States ensured 100% deployment of sophisticated FM radio systems across its entire armored fleet. The heart of this mobilization lay in factories like Motorola's Chicago plant. Before the war, this company manufactured consumer car radios, but its conversion to military production required complete retooling and immediate resolution of unprecedented technical challenges inherent in battlefield electronics. The resulting equipment was a marvel of complexity, requiring 2,748 individual components to be manufactured to exacting standards for each SCR-508 system. For instance, the BC604 transmitter alone contained 474 capacitors and 385 resistors. Crucially, the crystal oscillators had to maintain perfect frequency stability despite the brutal extremes of temperature and the constant, violent vibration of combat operations. The production statistics of this industrial feat tell the story of American might, 3,800 SCR-508 family radios were delivered in 1942, spiking to 11,400 units in 1943, and culminating in 24,000 units in 1944. Total wartime production surpassed 50,000 tank radio sets. This unparalleled production miracle guaranteed that every single one of the 49,324 Sherman tanks manufactured during the war received sophisticated, reliable radio equipment, an achievement unmatched by any other nation. Beyond simple frequency modulation, the SCR-508's crystal control stability allowed tank crews to precisely preset their channels. Maintaining unit alignment during the chaos of combat hinged on technological superiority. While the German Fuji 5 radios, relying on variable capacitor tuning, constantly drifted off frequency, American sets held their assigned channels with notable stability. This reliability was amplified by the SCR-508's sophisticated dual receiver configuration, which allowed commanders to monitor both their immediate platoon net and the broader company command net simultaneously. This system ensured orders flowed instantly down the chain of command, while commanders maintained continuous awareness of subordinate unit situations. Inside the metal hull, the BC-606 intercom system integrated seamlessly with the external radio, a critical advantage. Using throat microphones and noise-canceling headphones, every crew member could alert the commander to external threats with perfect clarity, a capability often absent in German tanks, where crews were frequently reduced to communicating by touch or desperate shouting amidst the din of the engine and battle. Another critical American advantage lay in superior power management. The SCR-508 system operated efficiently on either 12 or 24 volts, automatically adjusting to the available electrical supply. Crucially, the dynamo motor power supply delivered a stable, filtered current that eliminated electrical interference. Conversely, German radios, often powered directly from the vehicle's raw electrical systems, picked up every spark and surge as disruptive static. The cumulative tactical advantages afforded by universal radio deployment fundamentally transformed American armored doctrine. The reliance on reliable communications enabled the flexible combat command structure, allowing for the rapid organization of ad hoc battle groups and task forces tailored for specific missions. This fluid capability, which permitted American commanders to coordinate disparate units confidently through compatible radios, proved baffling to German commanders, whose rigid organizational structures were often necessitated by their own technological limitations. The limitations imposed by poor communications often masked the true technological disparity on the battlefield. A stark example emerged during the brutal battle for Ericourt in September 1944, where the U.S. 4th Armored Division confronted formidable German panzer brigades fielding the technically superior Panther tanks. While the Germans enjoyed overwhelming advantages in both armor protection and sheer firepower, the American system of ubiquitous radio coordination proved decisive. Unlike their adversaries, every U.S. Sherman tank possessed the capability to instantly report enemy positions. This real-time network allowed tank destroyers to receive crucial targeting data from units they had no visual contact with, and enabled artillery observers, often positioned in Sherman command vehicles, to call in devastating barrages within a critical span of mere minutes. Over 3 weeks of continuous engagement, the 4th Armor destroyed 281 German armor vehicles while losing only 41 Shermans. This staggering 7-to-1 kill ratio fundamentally defied the technical specifications of the opposing armor. Crucially, German intelligence consistently failed to grasp the profound significance of this American communication superiority throughout the war. While combat reports acknowledged the seamless coordination of U.S. units, they invariably attributed this efficiency to rigorous training, overlooking the underlying technology. A captured German intelligence assessment from September 1944 confirms this profound misjudgment, stating, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." The assessment entirely bypassed the technological reality. Consequently, German tactics never adapted to the true capabilities of the U.S. forces. They continued the futile practice of targeting perceived command tanks based on antenna configurations, failing to realize that every single Sherman could coordinate battlefield responses. They persisted in planning ambushes based on the flawed assumption that American units would fragment when visually separated, fundamentally misunderstanding that constant radio contact maintained inviolable unit cohesion, a reality that persisted through March 1945. As U.S. forces pressed toward the Rhine, the operational advantage afforded by their communication systems reached a critical apex. The dramatic capture of the Remagen Bridge immediately underscored the breathtaking speed of American command and control. When the reconnaissance elements of the 9th Armored Division sighted the Ludendorff Bridge intact, critical radio reports flashed back to 1st Army headquarters within mere minutes. This instantaneous intelligence allowed divisions across the entire operational front to pivot and shift exploitation forces within the hour, seizing the unexpected opportunity. In stark contrast, German forces were crippled by their reliance on fixed telephone lines, which American tactical aircraft systematically targeted and destroyed. Lacking comparable radio coordination, the German High Command proved incapable of matching the speed of the Allied response. The ensuing American radio coordination not only secured the bridgehead, but created an impenetrable, dynamic defense. Tank platoons drawn from disparate battalions integrated seamlessly, coordinating highly effective combined arms fire through secure radio networks. Consequently, the poorly coordinated German counterattacks, arriving piecemeal due to catastrophic communication failures, were isolated and destroyed in detail. This operational dominance reached its devastating culmination in April 1945 with a massive encirclement of the Ruhr Pocket. American armored columns from both the 1st and 9th Armies executed a complex double envelopment, a critical maneuver coordinated almost entirely through sophisticated radio communications. Inside the resulting Kessel, 325,000 German troops found themselves irrevocably trapped, their fate sealed largely by the total collapse of their communication infrastructure. Forward air controllers, guided by radio, directed American fighter bombers to systematically annihilate remaining German communication nodes. Isolated Wehrmacht units lost all contact with higher headquarters and, crucially, with adjacent formations. The depth of the German plight was grimly revealed in Field Marshal Walter Model's final desperate messages, dispatched just before his own communications failed. No contact with adjacent units. No communication. While fighting continued, the lack of coordination within the German armor formations proved fatal. The American superiority in radio technology profoundly reshaped the psychological landscape of tank warfare. For American crews, the knowledge of constant connection, even when physically isolated by smoke or terrain, provided an essential lifeline. They were never truly alone, linked instantly through radio waves to higher headquarters and adjacent units. German tank crews, conversely, suffered the inverse, a profound, isolating silence, unable to communicate across the battlefield. Their tanks often fought as individual, disconnected strong points within larger engagements, rendering coordinated maneuvers impossible. Even Germany's most successful tank commanders recognized this deficiency. Otto Carrerius, in his celebrated memoir, Tigers in the Mud, detailed the tactical nightmare created by limited internal and external communications. This technological disparity extended far beyond the immediate engagement. The relentless tempo of American advances during 1944 and 1945 was sustained by radio networks that German forces could simply not match. The Third Army's legendary race across France, for example, relied upon maintaining command and control across hundreds of miles instantaneously. German commanders consistently misjudged American operational capabilities, unable to fully grasp the depth of communication superiority the Allies possessed. Heinz Guderian, serving as Inspector General of Armored Troops, recognized this critical vulnerability. In a blunt December 1944 memorandum, he acknowledged that sophisticated American coordination effectively negated Germany's inherent advantages in tank quality. After Germany's surrender, American technical intelligence teams thoroughly evaluated captured German equipment. Their findings confirmed what combat experience had long suggested. While often superior in armor and main armament, German tanks critically lacked the sophisticated communication infrastructure required for modern, integrated warfare. While German armored vehicles often benefited from superior armor and armament, their battlefield potential was catastrophically undermined by inferior communications capabilities. U.S. Army Technical Intelligence Report Number 176 concluded unequivocally that German tank communications equipment lagged approximately 5 years behind American systems. The critical vulnerability stemmed from the absence of frequency modulation FM, severely limited radio distribution across their formations, and poor electrical suppression, which collectively crippled tactical coordination. This profound deficiency was confirmed by Soviet evaluators. The Red Army, having analyzed captured material, decisively chose to copy robust American radio designs rather than unreliable German systems for post-war development. The sheer magnitude of American technological supremacy is revealed by production and deployment statistics. American output exceeded 50,000 radio units, ensuring a 100% deployment rate across the 49,324 Sherman tanks produced. These powerful 25-watt systems, crystal-controlled to a precise stability of plus or minus 0.01%, maintain reliable moving ranges of 7 miles. Conversely, the German war economy produced only about 6,000 Fug-5 transceivers for approximately 12,000 medium and heavy tanks, resulting in a deployment rate of roughly 20%. These systems operated at a mere 10 watts with poor variable frequency stability, plus or minus 1%, often limiting effective moving range to less than 1 mile. The operational disparity was absolute. American tanks achieved 100% coordination, executing supporting fire missions in a rapid 3 to 5 minutes. German units, lacking reliable communication in 80% of cases, saw their average fire mission time stagger inefficiently from 15 to 30 minutes, condemning them to tactical isolation and delayed reaction. The superiority achieved by the M4 Sherman's radio systems established foundational principles that continue to govern modern armor doctrine. While contemporary main battle tanks utilize advanced digital communication suites, their operational requirements, universal deployment, and reliable coordination trace their direct lineage back to this wartime innovation. Recognizing this critical imbalance from their wartime defeat, the German Bundeswehr, rebuilt in the 1950s, prioritized communications, ensuring every Leopard tank manufactured carried comprehensive radio systems. Indeed, a Bundeswehr training manual explicitly codified the lesson: the defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. Modern conflicts offer stark validation of this doctrine. In the 1991 Gulf War, coalition forces leveraged superior communications to systematically destroy Iraqi units equipped with individually superior Soviet-designed tanks but inferior radios. American forces again demonstrated in 2003 that network-centric warfare decisively defeats platform-centric engagements. The story of American radio superiority was a victory secured in the electromagnetic spectrum, proving more decisive than any marginal advantage in armor or firepower. German tank crews fought their war partially blind to this revolution, discovering too late that the M4 Sherman, equipped with the pioneering SCR-508 radio, was not just a fighting vehicle, but a crucial node in history's first integrated battlefield network. This capability transformed the adequate medium tank into a component of a cohesive weapon system that included every American vehicle on the battlefield. The definitive advantage of the Sherman tank lay not in the capability of its 75mm gun or the angle of its sloped armor, but in the 181 pounds of radio equipment that linked every crew to the entire American armored formation. This constant connectivity cultivated a collective intelligence, a decisive strategic edge that no individual German tank, regardless of its inherent superiority in armor or firepower, could successfully counter. German forces encountered this brutal reality repeatedly, from the disastrous initial engagements at Kasserine Pass in the mountains of Italy, through the grinding attrition across France's dense hedgerows, and into final desperate battles fought within Germany itself. American units consistently demonstrated a level of tactical coordination that German armored doctrine deemed impossible without continuous visual contact. The Wehrmacht never successfully developed a countermeasure because they fundamentally failed to grasp the technological disparity. Whether accurately quoted or merely apocryphal, Field Marshal Wilhelm Keitel's reported observation at Germany's surrender We knew how to build better tanks, but you knew how to make them work together. Captured this profound truth. America had constructed not just 49,324 Sherman tanks, but 49,324 active nodes in the world's first effective armored battlefield network. The revolution in military affairs that historians now identify as modern network-centric warfare truly began in 1942, the moment the first Sherman tank, equipped with the SCR 508 radio, entered active combat. From that point forward, the dynamics of ground conflict were irrevocably altered. The side possessing superior communications would inevitably defeat the side relying solely on superior weaponry. The network had triumphed over the platform, ensuring that the connected would overcome the isolated. The German High Command fundamentally misjudged the true technological foundation of American battlefield success, fixating instead on the visible metrics of armor thickness and gun caliber. By the time German commanders comprehended that virtually every American M4 Sherman tank possessed standardized communication capabilities, a level of technological integration profoundly lacking in their own armored divisions, the strategic momentum of the war had already shifted decisively. This persistent inability of the German military to recognize and adapt to American communication superiority ranks among the most profound intelligence failures of World War II. Despite relentless battlefield evidence demonstrating the overwhelming advantages of American coordination, the German leadership never allocated the necessary priority to remedy their critical communication weakness. They continued to engineer technically superior panzers, formidable machines that, tragically for the Wehrmacht, often fought as isolated individuals. American forces, meanwhile, fielded merely adequate tanks that operated as cohesive, synchronized teams. In the ultimate balance of power, the silent electromagnetic waves carried by the American SCR 508 radios proved exponentially more powerful than the kinetic energy delivered by the German 88mm armor-piercing rounds. The ability to coordinate rapidly, to share critical intelligence instantly, and to fight as a unified fluid force rather than as a collection of singular vehicles became the invisible determinant of victory, overcoming any visible superiority in armor or armament. This decisive radio superiority changed the face of armored combat forever, establishing the immutable principle that in modern warfare, connection equates to survival, while isolation guarantees operational defeat. German troops discovered this brutal reality across 3 continents, learning too late that the Americans possessed not merely numerical superiority, but technological dominance in the dimension that mattered most: the ability to fight as one integrated unit.